Good morning, friends. It gives me immense pleasure to be here on my course, Aircraft Systems. I am in the process of case studies on aircraft systems. Today, my topic is a case study on fly-by-wire system of aircraft. As you know that this aircraft systems course contains module 1 to module 5 that I have already completed. In my module 1, I have covered the module 1, it is Introduction to Aircraft Systems, which covers the 4 major topics, that is Introduction to a structural system or airframe, then Introduction to vehicle system, then Introduction to avionics system, then Introduction to mission system. If you talk about aircraft structural system or the airframe system, it consists of wings, fuselage, empennage, and so on. We have also discussed about the internal configuration and how these wings, fuselage, and other things are made of. Different parts, they are working, everything I have discussed in my module 1 about airframe systems. Then if I talk about vehicle system consists of the electrical system, hydraulic system, pneumatic system, engine system, flight control system, and so on. This topic, fly-by-wire, comes under the aircraft control system, which I am going to discuss in detail about the fly-by-wire system in due course of time in the following slides. Before I go further, we can see that in aircraft we also have the avionics system, and in avionics system we have the communication system, navigation systems, and computerized sensor systems. In communication system, we have to communicate from aircraft to ATC, ATC to the aircraft, aircraft to the ground stations, from ground station to aircraft, and so on. Aircraft has to be given some information, and the pilot may ask some help or some other requirement. We need some communication system. Same way, if we have to go from one place to another place, we should get the proper direction. How the direction is achieved, what should be the speed and its orientation and all. This comes under the navigation system. So, and the last we have the mission system. If you talk about the mission system, we can tell that it is very much suiting for the military aircraft. Military aircraft, if you talk, it may be the fixed wing airplane like fighter aircrafts, cargo aircrafts, or the helicopters. These are used for different missions. Like for helicopters, we use for the cyclone relief, for the flood relief, for fire relief, for emergency, ambulance, and so on. These helicopters are also used for the anti-submarine warfare. They are also used for the sonar, for location of the submarine and other purposes, and also for different purposes the helicopters are used. Same way for the aircraft also we have the reconnaissance mission, surveillance mission, flood relief, cargo operations, war, and so many activities our aircrafts are doing. This is called the mission system. Today I am here the fly-by-wire system. So before I start the fly-by-wire system, I should first understand this is a part of the control system of the aircraft in which there is 3 motions. Just I will show this aircraft here, it will be better. So if aircraft is here and it is flying like this is the X direction or the longitudinal, and this is the Y direction or the lateral, and this is vertical from top to bottom, it is the vertical axis. So horizontal axis in longitudinal, and this is horizontal, it is the lateral, and the vertical is yawing axis. So we have the longitudinal axis, lateral axis, and the yawing axis. So if aircraft is moving in this direction, it is a longitudinal direction, and if it is moving sidewise, it is in the lateral direction, and if it is moving up and down, it is in the Z plane or the vertical direction. So we can have that there are three linear motion in X direction, Y direction, and the Z direction, and there are three rotation motion. First one with respect to the lateral axis or Y axis. So aircraft will do pitching. It is called the pitching. So pitching is obtained by the lateral with respect the motion of the nose. If it is going up and down with respect to the pitching axis, we say it is a pitching motion. And if the aircraft wing is going down or up like this, so it is with respect to longitudinal axis, and this motion is called the rolling. So rolling of the aircraft is achieved by the axis which is called the longitudinal axis. So there is a confusing here that the longitudinal motion with respect to the lateral axis and the lateral motion with respect to the longitudinal axis. And there is a third one which is called the yawing. Yawing is happening with respect to the yaw axis or the vertical axis. In this, nose will go either left or the right. So these are the three motions of the rotation and three motions of the linear motion. So now I will go further, and as you know that I am covering fly-by-wire system of the aircraft, and these are the topics which I am going to cover, topics of the lecture and the CO mapping. So first topic I will go for the revision of the flight controls, that is it is covering the CO6 actuation system. It is CO6 also, all of the CO6, it is a module 5th. So all these units will be covered. Then fly-by-wire actuation, electro-hydraulic actuation, control laws, Airbus fly-by-wire. A small diagram for Airbus I have shown here. So I will go for the revision of the flight control, and just now I have explained we have two major division of the flight control system. One is the primary flight control, that is covering roll, pitch and the yaw. Just now I have explained with the aircraft. Further I will explain. And next is the secondary flight control. In this secondary we have the high lift control, flaprons and slides and speed brakes. These are the and these references are from 1 and 2. These things are referred by 1 and 2. I have shown here. Okay. So primary flight control, we have the roll, pitch and yaw. Here this I have shown this diagram here. This you can see here that A. If I want to roll, first I will discuss about the roll. The main control for the roll is aileron. And what is the location of the aileron? Ailerons are situated at the wing tip. Not at the root, but wing tip at the leading, at the trailing edge. So this is the leading edge. And this side is, it is called trailing edge. So the location of these ailerons are at the tip near the trailing edge in both the wings, here and here, A. Both are the ailerons. These are the ailerons. So now if I want to make a roll, then what I have to do? So if you see here, pilot is sitting here. Pilot has to move either left or the right. It has to like this. It has to make left. Left will go down. I will just explain. And if I want the right, right will go down. So just you can see here. I think it will be better if I show like this. These are the ailerons. This is the right aileron and this is the left aileron. I think it is very much clear. I think I should make like this. Yeah. So it is like this. So if I want to make this wing down, then what I have to do? I have to this is a stick. Pilot has to make this stick like this. So this wing will go down. If I want to make this wing, from my side it is a left and from it is a right. So if I want to make lift this wing down, roll down, left wing down. So this is the stick. Pilot has to make towards the left. So here it is shown. If you can see here, this is the same stick here. So what will happen? If I want to make, this is the front and this is the back. So this is the left and this is the right. It should be very much clear to each and everyone. The pilot direction we have to consider. So pilot is sitting somewhere here. This is the pilot. So if he want to or she want to make roll left or the right, assume pilot want that this left wing has to go down. Then what he has to do? He has to or she has to make this lever towards the left. So if he is making lever towards the left, then what will happen? This will go down. The right aileron will go down. This is down, I am showing here, and this will go up like this. This will go up. So what will happen? The flow is coming from this direction. The angle of attack due to this aileron is increased here. So lift is increased like this, lift force, and here it is going up little, it is reduced. If previously it is this much, now it is only this much. If previously it is this much is increased. Okay, so I will show here, it will be better. Initially this is the lift, but if you make down, then further this much will be increased. This is L. Here also I will show. Here also both are L. So as you make this thing down, then here L1 will be increased, and from here if you make up this from here to here, this L1 will be decreased. So there will be a difference. Next, you just assume that this is the L prime total, and here is this is the L double prime. So L prime minus L double prime is the difference in lift due to change in aileron position. I think it is very much clear now how these ailerons are working. Okay, so roll I have completed, and same opposite also. If you want to make right wing down, this has to go down and the right aileron has to go up. So this is the basic principle of the roll. Now I will talk about pitching. So what is the pitching? Just now I have explained the pitching. If you see this aircraft, if I want to make pitching, means your nose should go up or nose should go down in the vertical plane. Vertical plane means this is the Y and this is the Z. In YZ plane, your nose will go in YZ plane like this. So that is your pitching. Pitching is achieved by the help of another control. The name of that control is elevator. So here this C is elevator, A is aileron. Okay, so here it is shown the C. So what I have to do? Suppose I want to make nose up. Then what I have to do? I have to make a force which is pulling down, because CG is here. So force into this distance makes the moment arm. So this moment arm into force. So I need a force because I want to make up. Then I want a force which is pulling down like this. So what I have to do? I have to make elevator upward. If I make the upward, force will go downward. If I make this downwards, force will be upward. Okay, opposite. So if I want to make nose up, I want here force should be downwards. So I have to make this. These are the elevator black in color. This you can see black here and here. These are the elevator. So if I want to make nose up, elevator will go up. If I want to make nose down, elevator will go down. Because the forces will act opposite direction of the deflection of the elevator. By the Newton's law, Newton's third law, we are using in this. So if I want to make nose up, there is a stick here. This he has to pull towards this. So if it is pulling like this or like this, it is pulling, nose will go up and down. So here the angle of attack, if I want to make up, this has to go up like this. So force will act in this direction. So it will, CG is here, assume. So this into this distance, it will pull and nose will go up. So this is called the nose up pitching moment. Nose up pitching. And opposite will happen if I push like this, then angle of attack will increase like this. Force will be here like this and it will make like this. It is a nose down pitching moment. Okay, that is the difference between roll and the pitch. Next is the yawing. So if I talk about the yawing is the motion with respect to the vertical axis. So here, if I want to make nose left or the right, like from here, nose left or the nose right. So what I have to do? There is another important control that is called the rudder. Here is the rudder. Rudder is always in the vertical fin at the end of the vertical fin. So this is happening. The control name is rudder. This rudder is also there in ships, boats and all. There also because we want to make nose left and the right. So rudder is very old technology comparing to the elevator and the aileron. Ailerons and these things are used in aircraft. However, the birds are also having the same type of features which they use in due course of time as and when we require. But the rudder, if you see, it is not in birds. Birds do not have the rudder. But our ships, boats, all water locomotives, they have the rudder to have the yawing left or the right. So how this thing will happen? If I want to make nose left or the right, so this is the rudder here, yellow color. This is the rudder. This rudder, if you make towards the right, nose will go towards the right because force will act towards the left. So from the CG, it will pull like this, aircraft will. So in which direction you want to make nose, same direction you have to turn your rudder. So that is the importance of this rudder. So I have covered this main topic of this primary flight control. Next we have the secondary flight control system. Here we have the high lift control, flaprons and slats and speed brakes. So here primary and the secondary, this you can see here, flaprons are here. These are the flaprons. They are acting as a flap and the ailerons. So this is the flaprons. Here if you see here, this is the your speed breakers, speed brakes or spoilers also, it is called spoilers. So these are the things here. This also, this you can see here, different, this is the winglet to reduce the induced drag. Okay, so these are the parts, and here it is a slat. Slat is a leading edge flap. Other name, leading edge flap. These are the extruded out as and when requires. What is the leading edge? I think the front part of the wing or the front part of any airfoil is called the leading edge, and the back part behind it is called the trailing edge. So the slats are put at the leading edge of the wing And as and when during landing and the takeoff, pilot will operate a lever. By that lever, it will come out and the operation of this thing will be performed. So these are the high lift devices also, and this is flaprons and the slats I have shown, and the speed breakers are also here, which also I have shown. Now again I am going for the revision only. Flight control in detail, all these things are mentioned in this. This you can see here, ailerons are here. Then we have the outboard flap, and this is the inboard flap. Inboard, this is the inboard. And this is the outboard. These are the ailerons. Ailerons also, we have the outboard and the inboard. This is the out and this is the inboard. Okay, here we have the slats. I have shown, these are the slats, and this you can see in this, the slat is shown here. Same thing is visible here. This you can see by this diagram. If you see here, we have the rudder here. In this we have 1, 2, 3 parts. Elevator also we have 1, 2 here and 1, 2. So it is outboard and this is the inboard, like this. So here this is called the trimming tail plane. This tail plane will also can move. Here we have the roll spoilers. This you can see here, and these are the speed brakes. If you have the very this is the lift dampers. Lift dampers or spoilers are same. If you are making exactly vertical degree, 90 degree, it will spoil. And so I have given here some names and some I have explained about these things. So we can divide in this control into electrical control, hydraulic control, and the mechanical control. Electrical controls are elevator, ailerons, roll spoilers, tail plane trim, slats and the flaps, speed brakes and the lift dampers and trims. This you can see all here. They are all operated by the electrical system. Hydraulic actuation of all surfaces, and electrical and hydraulically everywhere hydraulic is there. All surfaces hydraulic systems are there. However, few things are mechanically also. They are hydraulically, they are electrically, but these are the mechanical, especially the rudder and tail plane trim. This zone, this you can see empennage zone. This zone is mechanical also. They are also electrically and hydraulically, but they should be also operated by the mechanical, because this both control, the redundancy of the system has to be increased. To increase this redundancy, we should use this type of systems. Now, types of flight control system, we can, just now I have shown you here, mechanical control, that is flight linkage system, electromechanical control using hydraulic actuators, then we have the fly-by-wire systems. So these are the three main types of control systems which normally we use in all the aircrafts. So first I will discuss about two types of mechanical systems, mechanical control system. One is the push-pull rods, another is the wire and pulleys. So here in this very old systems, in this we have the mechanical linkages. I am just going to discuss about each part of this diagram. So this I have taken from the reference 2. So here we have some inertial systems. These are the pilot controls and these are the pedals. So this aircraft yawing, nose left and right is done by the pedal. So if you see here for the, this is called control column, and here aileron trim actuators, aileron spring fill units, these things are here. Here we have the ailerons. Starboard means right. Starboard means right and port means left. Okay, so if you turn this control towards the right or towards the left, this is called the starboard, and this is called port. So if you want, you turn like this, this linkage of this from here, this will start, it will come this way and this way here. So if one will go up, another will go down. They are arranged in such a way that both will go in opposite direction for the aileron operation. But if you want to make pitching, means towards this, forward and the rear, nose down, and this is up, and this is the down, this is the right, and this is the left. I am writing LT, left. So, and these are the yawing here. Yawing is done by this. Okay, so if I want to aileron tandem jacks are here. These are the jacks. These, as it is operated, these valves are opening and the closing, and there is a hydraulic system. This, by that, these jacks will operate and they will go up and down as per the required conditions. Now, if you see that about the elevator, and this is the rudder. So, if I want to make the elevator up and down, then you have to move this forward or the rear, and this line will work. This you can see here, this line, and this will, there is a servo jacks here, tandem jacks. This will operate your tail plane. Or elevators are here. These are the elevators here, which is not shown in this diagram, I think. And here is a rudder. So these elevators or tail planes will move. If you want to make the operate to rudder, then you have to push this pedal. One is pressed, it means right side. So it has to move towards the right side like this, in this direction. So your aircraft will move right or starboard side. So here this, you can see the rudder Q field units are here. Everywhere field units are also there, which I have already described in my previous classes. So rudder trim actuators, rudder Q field, rudder spring field system, rudder PCU incorporated yaw dampers are also here. So this all things has to be incorporated for this mechanical control systems. Another very simple type of mechanical control system is the wires and the pulley system. And this is the reference here, reference 2 I have taken, and figure wires and the pulleys. So in this, in place of the rod which I have shown you in the previous, we have the pulleys. This you can see, these are the pulley and these are the wires. Everywhere we have wires and the pulleys and bearings and all. This you can see here, pulley. If you see, like these systems are used in helicopters mostly and all type of aircrafts. If you want to turn the angle of attack of your tail or your tail rotor of helicopter, that time we use such type of systems, and these are also working as the same as the push-pull rod which I have shown earlier. If you see that how our elevators, rudder and aileron will operate, we need some actuation system. It may be some electrical, hydraulic or mechanical. So there should be some jacks. So motion of the aircraft, that your control should be wide. So as you know that we have flaps, we have the ailerons, we have the elevator and the rudder. Pilot is operating, but how this will move? We need some system. That system is known as the actuator system. That actuator system will give the motion of every control. So that is the purpose of any actuation systems. So here we have the flight control actuation is very important. Evaluation is in ascending order. I have shown ascending. First, conventional linear actuation, old type. Then mechanical actuation with simple electromechanical features. Multiple redundant electromechanical actuation. So these very typical type of actuation systems I am going to discuss in my next slides. So here a conventional actuation system. In this, what happened that signaling by means of a mechanical links. So a signal or some forces are applied by the help of the pilot link. It is connected with the hydraulic piston actuators. So the signal is given by the mechanical links. Actuation by hydraulic power. So in this hydraulic power is supplied. So this you can see hydraulic power, a pump is there and the hydraulic system is there. These all things, and they will give to this valves. So this valve will give the hydraulic pressure to this system. As and when you give the mechanical system to this rod, then what will happen? This will open or close these valves. One will open, another will close. And as per that, the motion of this, either this direction or this direction will be achieved. And also we need a feedback. So from here, how much it is moved, this will be calculated and the feel will be given to the pilot. So it will be corrected. The pressure will be collected as per the requirement. So feedback is also very much important. So important aspect of this conventional actuation system is powered by a single channel. So here only one hydraulic power is given. In case of a critical functionality, dual channels are also given. Mechanical operated servo valve. Here SV, it is called the servo valve. These servo valves are operated by this mechanical linkage. No electrical is there. Only this rod will pull or push this valve. Accordingly, this valve will open or close. If it is there opening full, then a high pressure will be there. If it is partially, a partial pressure will be there. Accordingly, the motion of this hydraulic jacks will be getting, and pilot will get the feedback and it will experience on his hand. So mechanical actuation can accept a dual redundant system. In this we can get sometimes only two times the redundancy or the failure prevention systems. So here we can see that next is the mechanical with electrical signal. In the previous we have not given any electrical, only mechanical and hydraulic systems were there. But in this case, we have to see that mechanical actuation is also given. Here the signaling by electrical means actuation through hydraulic power. Pilot input is similar to conventional control. The addition here is autopilot signal. So here autopilot signals are also given. So this you can see here, autopilot inputs. Here is electronic servo valves. It will open and close. And here is the mechanical signaling, which is given by the pilot. And this will give to this link. It is same. Here only this part is here different. This is a new thing, which was not in the previous one. So from here, some special autopilot signals can be provided if pilot is adjusting the system. Now, flow diagram of a mechanical actuation with electrical signal. Just here is a pilot input. This pilot input is given to the mechanical signaling. From there, it goes to the movement of summing link for actuation. There is also a parallel system in this, and both are connected here. Autopilot signal, it will go to the electronic servo valve control. Then it is a mechanical signaling. Here is the same, and this is the same. So both type of systems. This is a pure mechanical. This one is pure mechanical or conventional. This is the electromechanical. So these are shown, and these are here reference number 2 is given. Now, in the previous only 2 times redundancy was there, but we need more redundancy. Means its failure rate should be very much reduced. If one is failed, another should take over. That is called the redundancy. So how much your aircraft is redundant, that much chances of the failure of the aircraft control system is reduced. So here adapted for the sake of the fly-by-wire. This type of multi-redundancy is used in the fly-by-wire system, which I am going to discuss in due course of time. What is the advantages or the pros of this? Reduced weight, improved performance, increased passenger crew comfort. First was used in Concorde, was the first pioneer aircraft in which this multiple redundancy system was used. as a fly-by-wire. Here this you can see here. Here we have the servo valve. This is the hydraulic system 1 and hydraulic system 2. So here we have, in previously we were having only one hydraulic system. Here we have the two hydraulic system. This will go to the servo valves. From here the servo valve position, it will change. Then it will go to the control valves. Then it will go to the actuator and it will move. And from here, position of the ram is obtained. So it is multiple redundant. It is shown only two, but most of the aircraft we have the 4 types of redundancy. 4 times redundancy means one failed, second failed, third failed, fourth time also if failed, then only there is going to be a serious issue. So here it is shown just a electrical signal. This you can see here. This is the electrical signal. This. Then we have the hydraulic power here. Then this is called hydraulic signaling. So this, by this legend, you can find out what type of systems is working at what type of scenario. So this is the multiple redundant actuation system, and these are the advantages. It reduces the weight of the aircraft, improve the performance and safety of the aircraft, increase passenger and the crew comfort. So the aircraft will not feel jerk. All of sudden, if some cyclone or some turbulence of the wind is coming, aircraft, your control will automatically adjust it. Pilot need not to interfere on that. Now, if we talk about the modern and advanced actuation techniques, so we have the direct drive actuator. It is called DDA, direct drive actuator. Use electrical signaling for actuation. Next, we have the fly-by-wire actuation. I am going to discuss in detail. Next is the electro-hydrostatic actuator. Here, electrical signals that pass through the some control laws, efficient control of the flight control systems. Then electromechanical actuator, EMA, are also used. So electro-hydraulic and electromechanical. Here control laws, efficient control of the flight control systems are used. So this we have to understand that in this way we can work, and advanced aircraft nowadays, they are equipped with such type of systems. Now it is today's topic is fly-by-wire actuation. So we should very much focus on this diagram and how these things are working. So this is here it is given the reference to, and here if you see, we have in fly-by-wire we have the 3 modes: full fly-by-wire modes, direct electrical link modes, and the mechanical reversion mode. Then we have actuator control electronics. So these are the modes. Full fly-by-wire. Everything is done by the fly-by-wire. Next, we can reduce to electrical link mode only. So electrical only, just you have to press the button, your electrical system only work. Then in case of emergency, some electrical problem is also there, your hydraulic problem is also there. Then we have to only work with the mechanical reversion mode, just like you have seen the first one where I have shown the mechanical linkage or push-pull rod. So if you press like this, your rods will communicate to the system. So these are the 3 types of redundancy. It is available at this juncture. If you talk about this diagram I have shown here, here we have the pilot. Pilot will operate manually here or by this type of, so it will go here. Then the signal will come by the autopilot, also this blue color. This will go to the actuator electronics, that is called ACE, actuator electronics here. Then this hydraulic power is given to this servo, and here is a LVDT. This LVDT will give motion to this rod, and here your any control, it may be the elevator or aileron or rudder and so any other things. So this will move as per this pilot control or the autopilot control, it will give the pressure. Accordingly, this will move left this side or this side, and if it can rotate also. And so here this hydraulic and this analog loop closer, it is a valve. This valve or servo valve is opened or the closed either by the pilot or by the autopilot, and accordingly this feedback of this thing is given to this electronic control unit, actuator control electronics, ACE, and it will actuate this system as per the feedback. So this is a fly-by-wire. In that fly-by-wire command is given, and here the direct electric link. This you see FBW full. This is the full, and this is the electric, and then it goes to the mechanical. If he is switching off, the pilot is making off the system, this will only mechanical systems will work. So this all three I have explained by this diagram. Hope it is very much clear now. So in fly-by-wire, your electrical systems, your this hydraulic systems and mechanical systems all work together. It may be pilot operated or it may be autopilot operated. So both, if the pilot wants that, he will select the autopilot and pilot will operate. If pilot wants that, no, I want to have the relax, then autopilot will take over and he will select the autopilot mode, and your aircraft will fly in autopilot mode. You need not to disturb. Everything will be done by the autopilot. Now, next is the electro-hydraulic actuator. So by name itself, you can see that this electro-hydraulic means it is operated by electrical and the hydraulic. Both systems are working in this. So we need some electrical power. So here we use a three-phase AC electrical power, which drive the drive electronics, and AC is there. FBW and the direct electrical links are here. So this, you can see that power electronics and control laws for efficient operations. So we have to use power electronics and the control laws. We have three laws which I have already explained, and in due course of time I am going to explain this all three control laws. Then conventional system imposed continuous pressurization. So here we need the pressurization of the system. The hydraulic system should be pressurized. So conventional system imposed continuous pressurization. Then EHA draws the required amount as per the demand. So this EHA is what? Electro-hydraulic actuator. So this full system, in electro-hydraulic system, we have the power drive electronics, we have the variable speed motors, we have the fixed displacement hydraulic pump. These all systems are called the electro-hydraulic actuators. These electro-hydraulic actuators draw the required amount as per the demand. So what is the demand and how much I want to extend and how much angle I want to change? That as per the pressure of the pilot or the autopilot, this your LVDT will move this lever or this jack, and accordingly the angle and the required motion will be achieved. Three phases AC power to power the drive electronics. So we need three phase this power also. So this thing, three phase power, electro hydraulic actuators are also required, and pressurization of the system, hydraulic system is also required. Power, electronics and the control laws of these things are also required. Now the next system is electromechanical actuator. So as the previously I have discussed, similar to EHA. So what is the EHA? Electro-hydraulic actuator. So in this electro-hydraulic, now it is electromechanical actuator. So what is the difference here? We have here, if you see here, these things were not there in the previous one. If you see this, variable speed motor, fixed displacement hydraulic pump. But here if you see, we have the electric motor here, because it is electromechanical, electric motor, reduction gear and screw jack. We don't have the hydraulic system. No hydraulic is there. in this system. No hydraulic is present in this system. So that is the beauty in this. Only electrical and the mechanical will work, either fly-by-wire, and from the signal will come from direct electrical link to the ACE. And here 3-phase power supply, it will go, power will be power drive electronics. From here it will go to electric motor. This electrical motor will operate this reduction gear, and as per this motion of this gear, here is screw jack and here is screws are there. By this it will go like this or this as per the motion of this screw jack. So I think it is very much clear that it is electric motors are used to operate the jacks or to operate the different control system of the aircraft. Here control laws for the fly-by-wire. I have just now told that there is a, you see here power electronics and control laws. This word has come. Power electronics means it is motors and all which are generating the power, and it should be controlled. But what is the meaning of the control law? So here I am going to discuss about the control laws for fly-by-wire. Normal laws, basic control laws alongside conditional algorithms help to detect failures and to revert the system to alternate law. So first law is what? That's called the normal laws. Basic control laws alongside conditional algorithm help to detect failure and to revert the system to alternate law. So in normal law, if anything is happen, there is a algorithm. If it is not following the algorithm, then the failure will be reverted to the alternate law. It will go to the alternate law. So what is alternate law? Basic control laws without any additional handling. In case of any further failure, it should revert to the mechanical actuation. So first, if it is the hydraulic or electrical, the alternate law will take over, and if it is again failed, it will hand over to the mechanical actuation. Then it is called the direct law. Direct relation from control stick to the control surfaces, or this you can say it is a mechanical actuation. So these three laws are there. Normal law, that is the 1, then alternate law 2, and then direct law 3. So these 3 laws are depicted in this diagram. So in the normal law, everything will work nicely. Then most double failure is a computer, hydraulics or the ailerons. If these things are failed, this will give to the alternate laws. This alternate law, if further it is failed, it will give to the mechanical reversion. Now if you see certain triple or double undetected failures are there, then it will go give to the direct laws, and from here it will give to the mechanical inversion. So like this, we have the here 1, alternate 2, third is the direct law, and last, this is the fourth one, is the mechanical. So 4 type of redundancy is available for the aircraft, and we have to make sure that your aircraft should not get failed. You should try to get the things as per the required conditions. Now I am in the last slide, and whatever it is told, this reference. So I am showing here the Airbus A320 fly-by-wire. In this, I need the 7 computers. We should have the 7 computers. This you can see 1, 2, 1, 2, 3, and 1, 2. Okay. So ELAC, this is the elevator and the ailerons here. Here is FAC, flight augmentation control. Here is spoiler, elevator, and the computer. This is called the spoiler, elevator, computer, and this is a flight augmentation computer. So these are the 7 computers are present here. And if you see here, GND special Here special LAF, SPD brake, SPD brakes, IF, roll. So roll, yaw and pitch. Accordingly, EL, EC, SEC and SEC here. Here normal and the stability, standby. So it is the right and this is the left, BZ. So here if you see EL, AC, 1, 2, 2, 2, this all are the operating the elevator here. Y, yellow and the blue, and blue and the green. So these are the hydraulic systems which are working, blue and the green, and here the all the elevators of the outboards are working with the blue, but inboards are for right side it is a yellow and for the left side it is a green. If you see here the rudder, this is the rudder. Rudders are working with blue, yellow and the green. 3 parts are here, and here is the mechanical also. It is a mechanical also is given. So yaw dampers, actuators here, FAC. So this will work here, rudder and all. So FAC1 and FAC2. Here 2 computers are here. This will try to work and make it all right. So here we have these are the references which we have to see that Wire I and the Seabridge A, aircraft systems, mechanical, electrical and avionics systems, Professional Engineering Publishing Limited, London, ISBN number, this is, and another book of the same author is Design and Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. Any questions? It will be nice if you can ask me the questions. This is my email. So any questions, it will be great pleasure to answer. Hope you like this video. Try to subscribe and like it. Press the bell icon there to get your information. Hope you have learned, and be tuned for my next lecture also. Thank you very much for joining this lecture. We will see you in the next. Thank you very much for joining this class.
Like, share and subscribe. Hit the bell icon for more updates.